Making its first appearance in the 2010 video game Mass Effect 2, the planet Tuchanka is the desolate and scarred homeworld of the Krogan species. Krogans are a spacefaring species of stocky, bipedal reptiles standing at an average height of 2.4 meters and weighing an average of 175 kilograms. They tend to be highly aggressive and warlike, and always resort to tribalism and vicious meritocracy to govern, regardless of the technological level of their society. Several millennia of brutal wars have left the surface of their planet broken and scorched, with frequent radioactive dust storms sweeping through the ruins of their once industrious civilization. Very few species of native flora and fauna have survived to the present day, and of those that remain, most display ferocious predatory behavior. The planet's population of 2.1 billion Krogans live mostly in squalor underground, only venturing to the surface rarely to gather resources and wage war with neighboring tribes. The planet Tuchanka is a wet terrestrial 30% larger than Earth and 1.9 times more massive. It has a mean density of 4.78 grams per cubic centimeter and a reported surface gravity of 1.14 g. But this is slightly inaccurate, as Newtonian calculations instead give it a surface gravity value of 1.1299 g. This discrepancy is likely the result of excessive rounding of values in the initial calculation. The planet has a surface water coverage of less than 20%, with the planet's remaining oceans being small, alkaline, and widely spaced. The planet's atmosphere has a nitrogen-oxygen ratio that is breathable to humans at a pressure only 10% higher than Earth's. But its surface temperature is reported to be very high, with the surface temperature stated to be 72 degrees Celsius. This is extremely high for a global average and prompted the construction of a sun shield at the planet's L1 Lagrange point, which reduces the average temperature to 36 degrees Celsius in the shaded areas. Tuchanka is the fourth planet of 6 in the system and is reported to orbit its single star at a distance of 5.3 astronomical units, with a period of 16.7 years or 6,099.7 days. But this is not physically possible given what we know of the system. Kepler's third law of planetary motion allows us to calculate the relation between a planet's orbital period, its orbital distance, and the mass of its parent star. To be scientifically accurate, Tuchanka would have to have either an orbital distance of 7.798 AU or an orbital period of approximately 9.36 years. This equates to 3,418 days, or 3,833.27 local days, given the planet's 21.4-hour synodic rotation period. Tuchanka orbits a spectral type F0 main sequence white star named Aralak, meaning Eye of Wrath in at least one of the planet's languages. It has a mass of 1.7 solar masses, which gives it a calculated luminosity of approximately 8.35 times that of our Sun. The star's high energy output sounds like it provides a good explanation for Tuchanka's high surface temperatures, but in actuality, this isn't the case. Orbiting at the reported distance of 5.3 astronomical units, Tuchanka would receive a stellar flux of just 405 watts per square meter, less than one-third the amount of energy that Earth receives from its sun. So Tuchanka's surface temperatures should be nowhere near as high as they are reported to be, and the planet would not have any need for its sun shield. So how does Tuchanka measure up scientifically? Tuchanka has a mass of just under twice that of Earth, which is a very common size for terrestrial planets. Additionally, it has a mean density of 4.78 grams per cubic centimeter, which is exactly what we would expect from a planet of that mass. They did get its surface gravity calculation wrong, but it was by such a small amount that I'm willing to overlook it as a rounding error and give its geophysical realism a score of +1. Unfortunately, I cannot be as generous toward Tuchanka's orbital realism, as at least one of its quoted orbital parameters is completely wrong. But since we don't know which parameter that is, it calls into question all of its orbital data and breaks numerous planetary properties that are derived from these values. -1 point. I'm sure the creators of Mass Effect thought that by placing Tuchanka around such a luminous star, it would guarantee that the planet would be as hot as they wanted it to be. And this could have been the case had they not then placed the planet so far from the star. Making it even worse, the lack of significant oceans on the planet causes it to have a fairly high albedo, or reflectivity, which causes most of the light that reaches the planet to be reflected away before it can heat the atmosphere. Greenhouse gases, such as carbon dioxide, could help retain what little heat the planet absorbs, but there cannot be enough CO2 in Tuchanka's atmosphere to result in the high temperatures it is reported to have, and its atmosphere still be breathable to humans. The planet's reported surface temperature was already unrealistically high for a global average, but given the problems with its other parameters, it is even farther from the mark. -1 point. Tuchanka has no moons, which is unusual for a science fiction planet, but quite common among actual exoplanets, so +1 point. The system's star is fairly well built, with the main exception being that stars of that mass only live for about 2.65 billion years, which is not long enough to evolve advanced multicellular life forms, such as Krogans. So it isn't a bad star, but it is bad for Tuchanka. 0 points. With a total score of 0 points, the planet Tuchanka from Mass Effect receives an E grade, which is, not good, but it could be worse. Thank you for joining me on this planetary exploration. From here, I'll be breaking orbit and plotting a course for yet another distant star system. I hope to see you there. Commander Aldridge, out.